Yeah, so let's assume that we have a data set of movie ratings by users. So here is the data set of 5 movies rated by 1, 2, 3, 4, 5, 7 users. Yeah, so we have Joey rating the 5 movies. We have Jim, we have John, Jack, Jill, Jenny, and Jane. And well, if we look at the data metrics a little bit closer, we'll see that we have kind of 2 homogeneous groups here. So we have the boys that like obviously these 3 things here, don't care too much about Casablanca. 0 probably means that we haven't seen it. So the guys here, they like these 3 movies here, probably, which could be somehow summarized by the concept science fiction, maybe. Yeah. And the girls, they like the 2 things here. They didn't take care too much about the science fiction movies, but they watched and probably also liked those 2 here, which are more on the romantic side. So maybe there is a second kind of concept, which is romance, yeah, displayed by these 2 movies here. Yeah, and these 2 concepts are actually displayed in the data matrix quite homogeneously. Yeah? So we have the first concept supported by these 4 observations here, by the 4 users here. They didn't care at all about the second concept, and the second concept is supported by these 3 observations users here, and they don't care too much about, or don't care at all about, the first concept. Yeah, so very homogeneous, and that is actually also displayed in the SVD. So if we take this data matrix here, so that is the same data matrix here, the D, yeah, as here, the ratings of Joey, Jim, John, Jack, Jill, Jenny, Jane, yeah, and the corresponding movies here. So if we compute this the support vector machine, yeah, the singular value decomposition of this data matrix, we actually get exactly this one here. Yeah, so O will be this one here, S will be this one here, and A transposed will be this one here. So what actually does these 2 things or 3 things actually tell us? Well, first of all, K is obviously 2, meaning that we have K, yeah, independent rows and columns. So the rank is 2, and that is actually absolutely true. Yeah, we have these 2 submatrices here that are perfectly homogeneous and absolutely independent of each other. So the rank of this data matrix, you see it also here, is 2, and that's why SVD gives us these 2 kind of concepts here, 2 independent columns, rows, submatrices here, yeah, which can be seen as concepts really. Yeah, and O actually tells us what is the relationship between the users, the rows, yeah, with these 2 concepts, and we see that, well, Joey supports the first concept. Not too much, but at least he supports it. He doesn't support the second one, obviously, yeah, which is this one here, or take this one here, the zeros here. Then Jim supports it a little higher, the first concept, also not the second concept. What is next? John also supports the first concept, yeah. So even higher than Jim does, and Jack also. Yeah, and all of those 4 guys here don't support the second concept. And with Jill, Jenny, and Jane, it's the other way around. So they support only the second concept, not the first concept. Yeah, so they are related to the first concept with different strength, obviously. Yeah, so we have 4, 5, 2, 0.6, 0.75, 0.3. Yeah? So also these numbers tell you a little bit about the strength, so to say, yeah, the relationship, the strength of the relationship. So O relates the rows to the corresponding concepts. S actually shows the strength of these concepts. So we have a little bit of higher strength in science fiction because we have more features and more observations, so more columns and more rows that somehow support this concept in comparison to the second concept, romance. Yeah, so here we have a little less features, columns, and a little less observations, rows, that support the second concept. Yeah, but they are close to each other. And A transposed now relates, well, we have the relationship between the rows to the concepts. Now we have the strength of the concepts. We now need also the relationship between the columns and the concept, and that is A transposed. So here we see that the first three columns relate to the first concept with the same strength. Yeah, makes sense. And the second two or the last two features, column 4 and 5, relate to the second concept, which is romance, which also makes absolutely sense. And that is even a little stronger, a little bit more consistent than the first one. Yeah? So that is what you get. Actually, sounds quite interesting, because you get first of all these independent submatrices somehow. Yeah. And of course now you can say, okay, actually I'm absolutely okay if I have just one feature for the first three, because the first three are absolutely redundant, especially for the first concept. The second two, those two here at the end, they are also absolutely redundant, basically related to the second concept. So in terms of, because we want to do dimensionality reduction, right? So in terms of dimensionality reduction, it would absolutely make sense to just compactify the first three to one feature, and the fourth and the fifth feature to the second feature. And that is actually what can be seen out of this SVD. And also those features here would be absolutely perfect, or that would be the A actually would be the new basis for a transposed or an optimized data set actually. Yeah. However, of course, in real world data, typically the data doesn't look like this one here. I mean, this is extremely artificial because we have a perfect discrimination between those two concepts. We have two very, very clear homogeneous concepts, and they are extremely discriminative. In real world data, we would have, of course, a lot of more noise here. So let's see if what actually happens if we add some more noise. And that is the next example here. So we have the same data set as before, at least here in these set matrices here. So still Joey, Jim, John, and Jack are fans of science fictions. They don't care at all about romance movies. Jill, Jenny, and Jane, the same as before about the romance movies. But now Jill and Jane says, well, maybe they are engaged with Joey and whatever, Jack, and they say, okay, I have mercy with you guys, so I do a big opfer and watch also Alien and rate it. Yeah, so Jane hates it. Maybe Jill says, well, was so, but anyway. Yeah, but you see here now we have two different ratings than before. So the whole thing is now not a clear two concept thing, but we somehow have a third concept here, and that is actually also revealed if we do an SVD, singular value decomposition of this data matrix here. So this is the new data matrix after we inserted here a little bit noise, this one here. And if you compute SVD for this data set, you get three concepts. You still have the two concepts, science fiction and romance, but you now have this third concept, which is somehow not fish, not meat. But anyway, and you still have the relationships of the users to the corresponding concepts. Yeah, you still have the strength of the concepts. The third concept has a very, very low strength, obviously, and you still have the relationships between the columns, the features, and the concepts. And now you see that, well, here it was really like very well structured. Now in reality it looks a little bit awkward, so you cannot really see too much from, well, you can see actually, but don't expect to have these perfect zeros here all over. So in reality you have a lot of small, extremely small values somewhere instead of zeros. But anyway, so what can we do with this information now, because still we want to do dimensionality reduction, we want to do feature selection. So how can we use this information here now for feature reduction?